Okay, you knew it was coming. We're in a chapter here. We've covered the basic idea of things. We've looked at the different techniques for solving these things. So of course, you know we're at about the point where we need to talk about word problems. So today, 11.4, we're talking about word problems. Specifically, word problems that end up giving you quadratic equations. So, there's a good news, bad news thing here. The bad news is, yes, it's word problems. The good news is, we've actually studied word problems that produce quadratic equations before. Back when you were learning factoring, you studied word problems that ended up with quadratic equations in them. So in a sense, there's not going to be anything new here today. The only thing that's really going to be new is that the quadratic equations that you'll deal with now, they may be a little more challenging than they would have been back when you were first learning how to factor. So some of the numbers will be bigger, some of the polynomials won't factor, you may need to use a calculator to work out some square roots, but the actual word problem structure is going to be the same as it ever has been. So I'm really only going to work one example because the word problem style of things is not new and different. Here's a very common type of a word problem. It's a distance, rate, time problem. When you read through it, you see some information about distance, then there's some talk about speeds, and then there's something about how long the trip took. So when you realize that what you're talking about is a distance, rate, time problem, you should instantly think of this formula here. In fact, this formula you should be so familiar with that you don't even really think about it anymore. You may not even have to write it down. It may just be sort of mentally automatic. The other thing that you should be doing with a word problem like this, a distance, rate, time problem, is you should realize distance, rate, time problems pretty much always have two journeys. And you can sort of organize all of your information into a little distance, rate, time chart where you're going to have the distance, rates, and times for the two different journeys all sort of organized together. It'll make it a lot easier to build equations if you set things up like this. So the question is, okay, what are the two journeys here? Well, one of them was a real journey that actually happened, where there was freeway traffic for 280 miles. So there's a real journey. And then the other journey here is sort of an imaginary one. If I had been able to go faster, then the trip would take less time. So there's a real journey and an imaginary journey that we wish we'd been in because we wish we'd been able to go faster. So when I say there's two journeys, they aren't always physical journeys. They aren't always real journeys. Like in this case, they can be imaginary. So then you fill in the chart with as much information as you can derive out of the paragraph that you're reading. Like for example, we know the distance. The distance was 280 miles. And it was also 280 miles in our imagination. We're not imagining that the distance was different. We're imagining the same distance. The main thing that's different here is we're imagining going faster than an unknown speed. So the real journey took, we don't know, call it x, for the speed, and the imaginary journey would have been faster. Once you have two elements of the chart filled in, you should immediately fill in the third one using distance equals rate times time. In particular, we're trying to figure out time, so we're going to take the distance and we're going to divide by the rate and we're going to get the time. So distance divided by rate in the real journey, distance divided by rate in the imaginary journey. And then that bit there is how you build the equation. Whatever you've sort of filled in from the formula in the chart, that's how you're going to build the equation. So we're going to build the equation by talking about time. What do we know about these two times? Well, the real journey took some length of time, and the imaginary journey was less time. So whatever number this first number is, this number down here is supposed to be smaller. And it's supposed to be smaller by exactly 1 hour. So if you take the real journey's length of time, and you subtract 1 from it, you should get the imaginary journey's length of time. All right, we're done. Well, we're not really done. I mean, we've built the equation, but it kind of feels like we're done because we're done with the hard part. We're done with the part that really requires you to put together a whole bunch of different pieces all moving at once and understand a big picture. Now we can sort of focus on how do I solve this equation? And you just have to do algebra steps now. So, what type of equation is this? Is this quadratic? No. No, it's not quadratic. It's a rational equation. It has denominators. This is going to happen to you. Wait and see. It will eventually be quadratic. But for right now, we're combining another idea into this. How do you solve rational equations? Well, we solve them by clearing out the denominators. We're going to clear out the denominators here by multiplying both sides of the equation by this, x times x plus 5. We multiply both sides of the equation by that. It'll clear out all the denominators we've got there. In this first fraction, the x's will cancel. And you'll have the x plus 5 and the 280. So we'll have 280x plus 5. In the minus 1, you do have to distribute to that, but there's no denominator to do any canceling, so it's going to be minus 1 times x plus 5. And then on the right-hand side of the equation, the x plus 5's cancel, and we have 280x. Do your distribution. Distribute in the 280 to this first set of parentheses. Let's see, 280 times 5. I don't know what that is. Let me get my calculator, just like everybody should. That's 1400. Here we're going to distribute in a negative x squared minus 5x. Aha, x squared. There's where this thing becomes a quadratic equation. And as soon as I see that x squared in there, and I know it's a quadratic equation, I have a new goal now. My goal now is to get everything shoved over to one side of the equation and factor. And if it doesn't factor, I'll use the quadratic formula. So let's see, which side do I want to shove everything over to? Well, I don't like the minus x squared, so I'm going to shove everything to the right-hand side of the equation, so that when that negative x squared moves over there, it'll be positive x squared. Notice that the 280x on both sides cancels out, and we're just left with a regular old plus 5x from shifting that to the right. And that 1400, when I shift it over to the right, is minus 1400. And then, since we've just recently learned the quadratic formula, I'm going to solve this using the quadratic formula. My gut is telling me that I think it factors, so if you'd like to try factoring it, go ahead, and you're probably right. I think it does factor, but I'm going to do the quadratic formula just for practice. So, quadratic formula. X equals negative b, so negative 5, plus or minus the square root of b squared minus 4 times a times c. Make sure you get that minus sign from that negative 1400, or this is all going to go really bad in a second, all over 2a. So inside that root, let me just grab my calculator and do it all in one run. That's 5625. And here's where I find out whether I could have factored it. Let's see what square root of 5625 is. Yep, I could have factored it. The square root of 5625 is just plain 75 with nothing left over. So if you had paused the video and factored it, congratulations, you're smarter than the teacher. Now let's continue. So, next, since there's no root here at all, we got to work out what the two answers are. One of them is negative 5 minus 75, so negative 80 over 2. And the other one is negative 5 plus 75, which is 70 over 2. So we've got two answers, negative 40 and positive 35. Oh, wait, no, that's not our answer. This is a word problem. And this is something you should always do in every word problem. When you think you're done, pause for a second, take a look, and see, did you actually answer the question? And we have not yet answered the question. The question was, how slow was the darn freeway traffic? And it's not negative 40. You're not driving backwards at 40 on the freeway. So that answer is eliminated because it's not realistic. But 35 miles per hour, that's a realistic answer, although I would be spitting nails if I was on the freeway and driving at only 35 miles per hour. No wonder I'm imagining, what if I could just go a little faster? I would have gotten home sooner. So that is at least an answer that could exist in reality, whereas the negative 40 was just not realistic at all. So notice how these things go. The structure is a type of structure we've seen before. We've seen distance, rate, time problems before. We've seen rational equations that have to have their denominators cleared out before. We've even seen quadratic equations like this before. The only thing that's different now is there's no guarantee that they're going to end up factoring or working out nice down in that last stage. So when I did the square root of 5625, I might have gotten a decimal in there. And this answer could have come out 35 point something something something. So be prepared for that. That's the only twist here in 11.4 that goes beyond word problems that you've done in the past.